Hello everyone. This is a community presentation by Advanced Cooling Solutions of Rack and Power Project Group, which is the immersion work stream, and the work stream which is working on the immersion standards or immersion requirements white paper. That's the revision 2 for this year. And I'm Jimil Shah. I'm an application development engineer at 3M EMSD Fluids Lab, along with Rolf Brink, CEO Asperitas and immersion stream work team leader for OCP. So basically, the goal for the objective for this document is this document outlines the requirements related to immersion technologies which may be considered for implementation in open compute environments. This document provides guidelines, best practices, general definitions, and requirements for liquid immersion cooled technologies for multiple purposes. The objective of the community is to create an unambiguous documentation collaborating all the immersion related technologies, whether it is single phase or two phase, using different fluids, different styles, and to create an environment for the end users and the vendors to come up with different technologies, different challenges, and different products and different solutions to for the open compute community. So the major contributors are Rolf Brink from Asperitas, Jessica Goldbrand from Intel, Nigel Gore from Isotope, John Bean from Schneider Electric, Rick Payne from Flex, and Jimil Shah, that is me, from 3M. So for the last year, Rolf Brink from Asperitas and the immersion workstream team leader, he presented on the revision 1 for this particular document. And for this, so first of all, this document is not is a requirement or a guideline. It's not a specification. So this document covers common terminologies, immersion specific measures with parameters of importance, and future specifications which can be used for different technologies, immersion related technologies and products. So in revision 1, we almost covered different immersion technology definitions, which covered single phase, two phase, enclosed chassis, tank style, open bath, or hybrid solutions. We also covered different feature classifications. We also covered quality and safety requirements, which includes certification compliancy, mechanical safety requirements, liquid management. Then we also talked about data center of, I would say, feature classifications, which includes standard management, thermal optimized solutions, high safety, high availability, high serviceability, and also rate-based definitions for common software platforms. We also talked about data center interface requirements, input-output differentiations, FWS compatibilities, and galvanic interface properties. We also talked about multiple requirements, and another objective from open compute is, so if we can come up with the best practices and the specifications using this document, so if we can come up with a checklist and we can use that, so the vendors and also the solution providers can use this, and follow that before applying for any kind of OCP logo. So I still want to give a little bit push on the comparable metrics that we already presented last year. We have mentioned this because this environment is completely different than the air-cooled environment. In air-cooled environment, you will be talking about the rack density on per square meters, also per rack. But here, this immersion cooled environment has the server which is dunked completely inside the dielectric fluid. So here we are talking about kilowatt per liter. And because here the fluids we are talking about using the different, I would say, measurements, we want to talk about the power density, because density we can significantly increase the power density with the immersion cooled environment as compared to air cooled or other cooling methods. And the reason behind that is the fin efficiency with liquid is far higher, far better than the air cooled environment. And considering the fact this environment is different, we will also have to talk about different terminologies which can be suitable for these standards. So again, I want to push on, and I also want to appeal the IT manufacturers and integrators to increase the density and do not limit yourself on the air-cooled based solutions. Increase the density which can be facilitated by immersion-cooled environment. So for the revision 2, I would like to discuss about the changes or the additions that we have done so far during the last year community calls, and we have initiated to talk about immersion based to split the document into best practices versus specifications. As I already mentioned, we want to provide the guidelines or checklists for vendors or the solution providers to follow so that they can apply for any kind of OCP logo. Then we have also included high availability requirements, then dielectric fluid quality management guidelines, which is very important because here we are talking about the dielectric fluids. There are multiple types of fluids available in the market, and there are so many uncertainties associated with that, and people are not aware of the shelf life. They don't know what will happen on the fluid property during the operation. Then we also want to discuss how can we maintain that, how can we manage the quality of the fluid, as well as we can keep the properties of the fluid intact. Then we are also going to discuss about the uptime factors and immersion qualification checklist, as I already mentioned, which will provide the guidelines for the OCP logo as well. I would like to hand over this to Rolf.
Yeah, thank you, Jamil. So the document split, I'm just gonna shed a little bit of light on that angle. What we intend to do is to split the initial immersion requirements document into two separate documents. First, we're gonna bring in the common context elements like metrics and terminology, which is standardized across the immersion cooling spectrum. And bring that into the white paper together with design guidelines regarding safety, form, factor, shape, and such. A lot of the advisories that are currently in the document regarding liquid management, EMC statements, containment, and many more of these things, including the new availability insights, and to combine all that into a white paper. Whereas we're separating the actual requirements that we're actually using to qualify immersion technologies into the OCP domain. We're going to bring that into a separate spec document, which we'll try and get through the incubation committee as well. One of the things that we're discussing around this is a recognition program which may or may not be aligned with existing logos or existing OCP claims. That is currently in discussion. There is nothing definitive, but this is the aim that this is what we're pursuing with the community. Then, as well, one of the new elements which is part of the white paper is newly introduced is the high availability requirements. So regarding the high availability requirements, we've already established a few feature classifications. This is one of the new classifications that we've described into the white paper by now. And the requirements for this is all aimed at high uptime. We're all familiar with high availability platforms, dual power, 2N systems, both in power and cooling circuits. This is supposed to outline some requirements regarding the qualification high availability. So before a solution can be stamped as a high availability solution, a dual power delivery and full sensitivity on the critical features must be proven and is certified, confirmed by an independent third party. Um, we haven't established what it actually needs to look like, but that's something that we're working on. But it also comes down to the ability to distribute redundant power to all the electronics inside an immersion cooling solution, and that should be N+1 or 2 and cooling ability as well, which requires basically the ability to connect to two independent water circuits, which should not be mixed, right? So two separate water circuits may have different properties. It shouldn't be. They should never be shorted out. So that means if you have an immersion technology that can connect to two water circuits, those circuits have to remain separate. So very similar to the electrical selectivity. However, there is one very specific element which is quite unique in this case when it comes to immersion technology, because the N+1 can be supplemented or even achieved with very specific write-through capabilities. Now, write-through is something that I'll explain later on in this presentation when it comes to the new high availability elements. But this is the interesting bit here, that it doesn't necessarily need to be two explicit heat exchangers, because availability can, with immersion at least, be solved in other ways as well. So with that little teaser, I'll keep you hanging.
Thank you, Rolf. So another classifications that we have recently added in the white paper is dielectric fluid quality management guidelines. The important part of this whole discussion is because there are so many uncertainties for pertaining related to the dielectric fluids. We have already included the properties, required properties for immersion cooling, the guidelines and requirements for liquids and their usage in the white paper already. But during the last year, we also realized that there is a need to provide the guideline to the end user, that what to ask from the vendor, and also for the vendors, what do they need to do to maintain the fluid quality so that they can provide the consistent performance. So as we all know, there are two types of major liquids available in the market for immersion cooled application. One is hydrocarbon and second is fluorochemicals. So based on the studies available in the market, in the open source as well as the past experience, we have listed some of the contaminants which can, which can affect on the performance or the chemical stability of the liquid. So we have also provided the contaminants, their sources, as well as the prevention or remediation solutions for the respective type of contaminants for the respective liquid. So as you can see in hydrocarbons, if you have the particles or fibers or human hair kind of contaminants, you can use the in situ filtration system and you can take care of that. There, so there are some fluids which there are some hydrocarbon oils have the effect of moisture on the chemical stability of that chemical of that oil. So that should be taken care during the manufacturing process, and when you have the authentic and uh, an ethical, a trustworthy supplier which can provide you all the information, or you can ask to them. This sludge formation is mainly related to mineral oil. It's not as much a big issue for synthetic oils, but it is also a property of the oil. Once the oxidation takes place, uh, sludge formation also occurs in the oil. So corrosive sulfur as well as the degradable products and soluble polar contaminants, because of because in electronics there are so many hydrocarbon polymer materials being used, and because of the incompatibility or any kind of reactions at different temperatures with the hydrocarbon fluids, it can create some soluble products or degradable products in the fluid. contamination by plasticizers, grease, adhesives, ink, elastomers, and solder flux, and it so the electronics and the supporting hardware can, I would say, uh, introduce multiple types of contaminants to the oil, and which can affect on the property of the oil, as well as it can also affect on the performance of the oil. So, and also, if there is a pool of these contaminants at certain locations in the hardware, it can also create some material compatibility issues. So all those issues can be prevented by the proper measures and by the proper, I would say, steps taken by the solution provider. And that's why the conclusion would be the properties of the oil in operation should be tested for oxidation stability, interfacial tension, particle count, flash point, viscosity, breakdown voltage, different parameters which can which can help you to monitor fluid quality, ensuring consistent performance over time, which can also be done during the operation or with the data points of up at the certain period intervals. The most important part over here is, based on the studies available in the market and the past experiences of the solution providers as well as the integrators and end users, mineral oils or the refined mineral oils or the blends of mineral oils should be avoided. Only synthetic liquids should be used, and because of the synthetic liquids, it can minimize most of the common malfunctioning related to immersion cooling, uh, can be solved uh, easily, and they are more stable as compared to mineral oils. But to ensure the consistent performance, we still recommend to have the testing of these properties in situ uh, uh, along with the operations. So fluorochemical fluids, as we know, these fluids are very inert and they don't have the direct affinity towards any contaminant. But as we have already mentioned in the IT gear document, uh, the the fluorochemical fluids can get contaminated by the electronics and their supporting components. Themselves. They may introduce the common hydrocarbon contaminants like DOP and PDMS to the fluid, and can affect on the quality of the fluid. So wire insulation, silicon rubber, solder flux, and those kind of sources can introduce these contaminants to the fluid. Similarly, chemically active hydrocarbons such as solder flux, which are already there on PCB boards with the surface mount components. And these all contaminants can be taken care by activated carbon, because activated carbon has much more affinity towards hydrocarbon, I would say, non-volatile hydrocarbon impurities than the fluorochemicals. So it can be taken care by the activated carbon in situ filtration system. Then water, it can happen by through the condensation or heat exchanger leak, that can be taken care by silica gel and metasulfate. Here, one thing is important, that water is immiscible with fluorochemicals, so that can be easily scrubbed out. Another thing is particulate, so we can easily use the mechanical filtration, are recommended to less than 1 micron, and also the decomposition products of the fluorochemicals themselves, that can be taken care by activated alumina or base wash. Uh, the the thing is, the fluorochemicals are inert, but in the case of two-phase immersion cooling, it can deposit by the method of distillation, and that has been discussed in the material compatibility section of IT gear guidelines document white paper. So the recommendation is, the system should be designed to remove water, hydrocarbon oils, acids, and thermal decomposition products. So fluid conditioning system should be there in situ the tank, uh, or the solution. Now I would like to hand over to Rolf again to talk about immersion related uptime factors.
So part of the new content in the immersion requirements at least for the white paper section, is some new descriptions around a principle that's called write-through, as in the first topic of this of uptime factors. And before we get into details around this, there's basically three main divisions of write-through, three categories of write-through. The first one is a dielectric write-through. Dielectric write-through basically describes the thermal buffer of the liquid itself, and the ability of the liquid to keep absorbing thermal energy without any kind of circulation or cooling system that is active. So think about a mechanically circulated solution where a pump fills. How much capacity is there in the liquid to keep to support a platform before the platform becomes overheated? Especially when following the immersion optimized IT equipment white paper, which is part of another presentation, this thermal buffer may be drastically increased. And the second type of write-through is the partial dielectric write-through. A partial dielectric write-through describes the principle of having, let's say, a 2N kind cooling system. Imagine two two heat exchangers, for example, or two CDUs that are immersed inside the tank that are fed with two water circuits. If one water circuit fails, that the remaining heat exchanger or CDU may not be able to maintain the environment in the tank in the exact same way as just one heat exchanger or CDU would. However, as soon as the temperature starts increasing in the tank, the efficiency of heat exchanging of a CDU or a heat exchanger will drastically increase. So you may actually still reach a stable situation, which is of different specifications, namely a warmer environment. But this is something that a platform or an IT deployment or a whole solution can be designed for. And this is one of the ways in which high availability could be engineered. This may also be implemented in a scenario where an overheating scenario is going to be delayed. So the thermal buffer itself with a dielectric write-through, with a pure dielectric write-through, might be sufficient to delay an overheating with, let's say, an hour. And in the regional summits in Amsterdam of 2019, I presented an actual failure scenario of a cooling circuit in one of the Asperger systems, which shows what the dielectric write-through actually does on the load. This is so that's basically an effect of delaying an overheating scenario. With a partial dielectric write-through, this kind of delay might actually be extended well beyond that scope of an hour to several hours or even a day, which allows a lot of time to fix any problems inside a facility. And then there is a third one, which is also interesting, which is the facility water system write-through. So imagine a data center that is running either partial or complete liquid cooling infrastructures consisting of immersion systems, or any kind of liquid cooling for that matter, whether it's rear door cooling or cold plate. The facility water circuit could be designed in such a way that it's got a built-in buffer of maybe a few thousand liters or more, which allows you to keep on circulating water throughout the facility to effectively keep cooling all the liquid cooled solutions in the facility. This is something that can be physically built into the facility, that can be completely independent of the technology. However, this will not be a solution for pump failure of the facility water circuit. So it all depends on which type of write-through you're designing for and which type of failures you're designing for. A second uptime factor is the thermal design of the solution. Now, this is also what the white paper focuses on. the white paper about IT optimization for immersion. And it's highly dependent on which type of immersion solution is chosen or is engineered for. And the dampening effect by the liquid, which is partially related to also dielectric write-through, is an effect that can be taken into account, which is to minimize stress on microcomponents. But also, very simply put, the ability to just rely on outside temperatures for cooling, which may fluctuate throughout the day and even the day and the night or throughout the year, without any significant thermal stress effects on the microcomponents, which greatly affects the lifetime of the IT equipment. Another effect is the thermal stability by controlling a very predictable flow in the solution, which allows much improved stability of chip temperatures. Because if the system doesn't vary throughout its operation, everything becomes stable. There is a lot to say for stability in this case, because the actual large temperature differences on components will cause physical stress on the components, because the materials keep expanding and shrinking back. And this is exactly what immersion, one of the elements of which immersion cooling tackles. A third topic here, actually, a few other minor topics which are mentioned also. Well, they're not that minor, but topics that are mentioned in the paper are alternate cooling sources as backups, which can be implemented on a facility-wide level. Think about rivers, pools, all sorts of natural sources of water, even the ocean can be used as a cooling source, whether the liquid is directly circulated through the facility water circuit, or whether it's a separated circuit with heat exchangers. Natural bodies of water can be very easily used as emergency sources of cooling. And one of the things that, I'm known for making a point of that, and it's part of a passion of mine as well, is that the fact that high temperature cooling, if you optimize for high temperature cooling, what you're actually generating is high value, high grade heat, which makes it much more attractive to consider reuse scenarios, because high grade heat is valuable. It's worth money in most areas in the world. Putting that into a reuse scenario effectively means that the reuser becomes your cooling circuit. And finally, one of the elements to consider is the fact that insulation against oxygen should be taken into account when thinking about uptime factors. Any kind of IT system that is immersed in a dielectric liquid is completely being insulated from oxygen, which means that there is no chance of oxidation. And this goes into the lifetime of IT equipment and the potential for failure of IT equipment. So there's more to come within the ACS Immersion group. First of all, we're going to be continuing the work on the IT gear optimization white paper, which is also being presented today, which focuses on the design guidelines for IT equipment, material compatibility, thermodynamics, which I think is one of the exciting topics, but also compatibility studies for immersion components, and future designs for IT equipment. For the rest, we're expecting immersion systems to come through in the community, which the immersion community will review and also hopefully qualify, as well as solutions and liquids. And a continued point of attention for the group is the optimization of industry standards, which we're hoping to see adopted across the entire industry. Which brings me to the final topic, which is the call to action. And that's very simply put, join the immersion workstream and do contribute. don't be afraid to contribute. This is a nice group. This is the fields at the edge of the technology where all the newest stuff is happening. The immersion call schedule is every third Thursday of the month. The wiki page and the mailing list links are on the end of this presentation. You can download this presentation after this session is finished. And we're hoping to progress all the documents that have been announced in these different presentations as soon as possible, and hopefully that will all be done soon. So thank you all for your attendance.
Okay, I'm not sure if anyone can hear me, but Jamil and myself, Rolf, we are available for Q&A.
Yeah, thank you everyone for joining the presentation and giving your time to attend this presentation.
Yeah, so feel free to ask any questions, people. I see that there's still a few people in the chat. If there are questions, this is the time. Otherwise, we'll close up the call. Okay, well, for everyone who has attended and still in the audio, thank you very much for joining. Appreciate your attendance, and looking forward to seeing you all or writing with you all in the other presentations that are still scheduled for today. Bye-bye.